viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhatta College. So in this lecture series of operating system concepts, we have in the previous lectures we have seen what actually an operating system is, and then from that we have moved on to the operating system structure. So in operating system structure, we have seen basically two categories till this point. One is a multi-programmed system and another one is the logical extension of this multi-programming system, which is the time sharing operating system. So a time sharing operating system, when works, it needs basically two concepts. One is the CPU scheduling and another one is the multi-programming. Now we understand what is a multi-programming system. So basically a multi-programming system is something which is having multiple jobs residing inside the memory, and those jobs are waiting for CPU. Now which job will get CPU, when it is going to get CPU, and for how much time it is going to get that CPU, this whole kind of concept comes under the terminology of CPU scheduling. So basically your operating system is also responsible for CPU scheduling. So this CPU scheduling is allotment of CPU to various jobs which are residing inside the memory, and they are waiting for the CPU to be allotted to them, and which jobs are going to get it first, which jobs are going to get them last. So basically kind of some prioritization between some prioritization of jobs to get executed, then for how much time they are going to get the CPU. All those are actually some policy decisions, and these policy decisions are being kind of implemented with the help of operating system, and all those comes under the CPU scheduling. So basically time sharing operating system uses CPU scheduling and multi-programming, and with the help of these two concepts, a time sharing operating system is able to provide each user with a small portion of time of a CPU, or we can say it is able to provide each user with a small portion of a time shared computer, and each user has at least one separate program in the memory. Now a program which is loaded into the memory and it is executing, that is known as a process, and when a process it executes for a short time before it either finishes or it need to perform input output. Now there are kind of very rare applications which need CPU on and on for a long time. So meanwhile, let's say we have a simple program, and that program needs something to be kind of printed onto the output screen. For example, it's a user message, then it may wait for some input. Let's say it's a sum of two numbers, then it will wait for two numbers to be entered by the user. So basically it's not the CPU which is going to attend the process all the time. It needs to perform some input output and some other operations as well. Now this input output, when we talk about, is kind of an interactive process which requires interaction with the user. So your interactive input output, for example, the output is going to a display for the user, then it is waiting for a key to be pressed by the user, and some other input which is coming from a user keyboard, or maybe a click from the mouse or any other device. So basically what point I'm trying to establish here is your input output is an interactive kind of activity which typically runs at a human speed. Human speed may be for example, let's say I can say typing 10 characters per second may be a very fast speed for a normal user, but it is kind of a very incredibly kind of slow thing for the CPU. So whenever there is an interaction with the user, the whole process get kind of delays down, and it may take a long time to complete. For example, input, when we are talking about, it is bounded by the speed of one who is typing. This is going to be very slow as compared to what in what measures of time your CPU is kind of operating. So CPU is operating very, very fast, and no matter how fast we claim as users we are, it is not as fast as computers. So rather than letting the CPU sit idle as this interactive operation of input and output is taking place, the operating system will rapidly switch the CPU to the program of some other user, and this is a very, very common activity in case of when we talk about your time sharing programming. So time sharing and multi-programming situations requires several jobs to be kept simultaneously in memory. Now what happened? Now you all understand that memory is a limited resource. So several jobs are ready to be brought into the memory, and they are waiting at the disk pool that someone should come up, take them up and load them into the memory. But what if there is not enough room for all of them, and it is a very, very kind of, we can say, valid and a genuine situation, because as compared to your hard disk or as compared to your secondary storage data, your memory is small. Then what? All of them cannot be brought simultaneously into the main memory. Then the system must choose among them that which one is to be brought, which one is to be sent back, for how much time your one which you have brought is going to be there inside the memory. So basically this is a process of taking many decisions which involves job scheduling, which job is going to get the CPU and when, which job is going to get the memory, and so on and so forth. So making this decision involves job scheduling, and with this we need that the operating system selects a job from the job pool and load that job into the memory for the execution. Now it is not only the decision of which is to be brought into the memory when, where it is to be kept. Now being a memory a small resource as compared to the hard disk, it also needs some form of memory management. So basically what is the agenda here is, when we talk about a time sharing system which needs multi-programming, which involves multi-programming also, here the agenda of operating system is to ensure a reasonable response time which is kind of quick enough from a user's point of view. Now what is to be done when we talk about that memory is small and jobs are more than the capacity of this? We need a swapping between the disk and the memory. Some jobs are residing onto the disk, they need to be brought into the memory. Now if the memory is already filled, some job from memory will need it to be kept back into the disk, and so on and so forth. So basically this goal of ensuring some sensibly small response time needs some kind of swapping, in which the processes are swapped in and out of main memory to the disk. So there is a swapping of jobs from main memory to the disk, and when we talk about the portion of that portion of the disk which is being used as main memory in order to keep the jobs, that is known as virtual memory. So a more common method for ensuring that sensibly sensibly fast response time is virtual memory. And what is the advantage of virtual memory is, the advantage of virtual memory is it enables the user to run the programs that are larger than the actual physical memory. Let's say your physical memory is 64 GB, or maybe let's say kind of 128 MB. Let's take a smaller example. So 128 MB, and your job which is being submitted, one job is of 136 MB. So how are you going to accommodate this into memory which is already having a capacity of 128 MB, and some of it is also being occupied by operating system and some other necessary routines. So this is possible with the help of a virtual memory scheme, and we will be covering this virtual memory scheme and all its related concepts like paging and fragmentation of jobs in the upcoming lectures. So basically this virtual memory schemes enables the user to run programs that are larger than the actual physical memory, and it abstracts the main memory into a large uniform array of storage, separating the logical memory as viewed by the user from the physical memory. So basically this memory management or this virtual memory scheme is going to separate out your logical memory view, which is being used by the seen by the user, as well as the actual memory, which is the physical memory. So both are managed in a kind of different way, and all these concepts like your kind of swapping, like your virtual memory management, your multi-programming system, as well as your some CPU scheduling or job scheduling, that comes under the time sharing system. So not only this, a time sharing system must also provide a file system, because the data which is related to various jobs is residing inside the different files. So those files, those folders are needed to be accessed on the need basis, and this is basically all those files are being basically managed by file system. So the file system resides on a collection of disk, hence the disk management must be provided. So when we talk about a multi-programmed system, it is not only the jobs which are going to be kept inside the main memory, it is much more than that, much more than just a multi-program system. Along with that multi-programming system, we need some CPU scheduling, because how to allocate the CPU and all those priority decisions, which jobs are to be kept inside the memory, which jobs will be waiting and sitting inside the job pool onto the disk, how to manage a particular part of the disk as virtual memory, what is logically giving, or what is the logical execution of your physical memory and your memory view of the user. Then we need dealing with some kind of a file system, which ultimately comes up under the topic of the disk management, and so on and so forth. So when we talk about many jobs or many processes inside the system, this needs a whole lot of working, and the overall controller or the overall we can say supervisor here is our operating system, who is going to manage the CPU scheduling, going to manage the file system, some disk management activities, some memory management activities, and so on and so forth. So all these things are to be managed by the operating system. Now in not only this, but in order to ensure the orderly and a proper execution of the jobs and not getting the jobs mixed, that's the first thing which we need. So in order to ensure a proper execution, the system must provide the mechanism for job synchronization and communication. So communication between the jobs is also very necessary, and this communication is going to take place with the help of a shared memory space. Now a shared memory space is something which is kind of used by all the jobs which are there in the race for resources. So job synchronization, job communication is required. So one job, if kind of is in the process of writing something onto that shared memory space, others are not allowed to write onto that space. So all these kinds of policy decisions, all those kinds of decisions so that the synchronization between the jobs is kept smooth are taken by operating system, and it is also required to ensure that jobs do not get stuck in a deadlock waiting for one another forever. Now let me explain in a kind of nutshell that what actually a deadlock is. Let's say there are kind of three processes, A, B and C. So job A or process A is waiting for the B to complete, B is waiting for C to complete, and C is again waiting for A to complete. So no one is able to move forward, and all the the system is in a condition of a halt, I can say. So this is a kind of situation which is better known as deadlock. So operating systems is job is also to ensure that the jobs do not get in a deadlock situation, and in case if they get in a deadlock situation by any reason, how to recover that situation. And before recovery, the operating system should try not to get these jobs into the deadlock. So not only the deadlock, but the prevention of the deadlock is also avoidance of the deadlock, and recovery from the deadlock is the responsibility of your operating system. So deadlock is a situation in which multiple jobs are waiting for one another and they are in a loop forever, or they are in a wait loop forever. So the operating system ensures that jobs do not get stuck in a deadlock. So till this point, what we have seen actually is, in the earlier lectures we have seen multi-programmed and time sharing system, and here in this lecture till this point we have tried to understood some nitty-gritties of time sharing systems, and along with the involvement of that for the implementation of time sharing system, various things are required. We need some disk management, because jobs are on the disk and they are to be kept into the memory. So when they are going to be kept into the memory, multiple jobs are there, so some kind of memory management is required. Some job scheduling is required, that which job is going to get which resources and when. Then CPU scheduling is required, that which job is going to get CPU and so on and so forth, and for how much of time, and then other decisions. So a time sharing system is, I can say, a complicated system which needs many variety modules of operating system, be it a time sharing operating system, be it a multi-programming operating system, and any other. Now when we talk about the views of operating system from a vantage point, we have various views of operating system from several usage points. So when we say what actually an operating system, or what makes an operating system, so there can be multiple views, we can say. So first, there are basically three views focusing on the operating system. One view focuses on the services that operating system provides, or so it it is having one different module for each type of a service. Now what service I am talking about? So memory management here is a service, CPU scheduling here is a service, then we have file management, then we have disk scheduling, and so on and so forth. So all those are services and many others. We will be taking this all these three views in the detail. So first view focuses on the services that system provides. So how operating system is going to deal with those services, or how your operating system is going to help your computer system in order to provide these services for the user. Another very important component of your operating system is about interface, and that we have seen in the earlier lectures as well, that it is kind of an interface, or it's a kind of platform available between the user and the hardware. So user is giving some command, hardware is supposed to execute that command, and if there is any error, that error has to be reported to the user. So either the execution, successful execution, or the error message that has to be reported to the user. So basically the operating system is some such thing which is kind of sitting as an interface between the hardware and the user, and it is making available the hardware to the users and the programmers. So that's the second view, which is based on the interface. And when we talk about the third view is what all kind of components your operating system is having, and what is their kind of, I can say, interconnection, how these components are connected to each other. So revising it, I can say there are various views of operating system from several vantage points, and the three views which are majorly available. One view which focuses on the services which are being provided by a system. Another view is focusing on the interface that it makes available to the user and programmer, and third view is about the components and the interaction between the components. And now we are in a situation to explore these views one at a time. So let us first begin with the view which focuses on the services that a system provides. So when we talk about your operating system services, operating system is like a government, it is also like a manager for the services or for the resources of the computer system. So basically what I am trying to say is it provides certain services to the programs, and it also provides certain services to the users of that programs. So it is not only the users which are getting services from the operating system, it is also your programs which are there in I can say at the receiving end from operating system point of view, and these services are provided for the convenience of the programmer or the convenience of the user. So now when we talk about this first view of operating system, which is basically focusing on what all services your operating system is going to provide, there is a figure on the screen which is going to give me what all kind of services are given by the user. So we have user and some system programs, then after the system programs we have a layer of system calls, and then the system calls we have many services. For example, we have input output operations, we have program execution, we have file systems, we have communications, then we have accounting, and then user interaction, privacy and security, all these. And this is actually not the exhaustive list, there can be many more. This is what is being provided by the operating system as the service either to the user or to the program. So here you can see after the services there lies operating system, and then there lies the hardware. So basically on top of hardware we have operating system, and top of operating system we have its components which is in the form of service modules, I can say. Then after that we have system calls, then we have user interaction, user interface, which could be of GUI or which could be of any other type, and then we have user and system programs. So this is basically a complete view of all those or we can say this is a stackable view of a computer system in which hardware is there, in which the users are there. So hardware is the bottommost layer and the users and the system programs are the topmost layer, and this topmost layer of user is interacting with the system with the help of user interfaces, which is the second layer. Then this user interfaces is followed by the system calls and the services, which are actually the components of operating system. So starting from the top we have users, we have interface, then we have system call, then we have services, then operating system, or more specifically we can say operating system core or operating system kernel, which we talked about earlier also, and then it is having hardware. So, if you can see the interface, the system calls and the services, if all these can be bundled inside the operating system, and these are actually the components of operating system, and let us say we make a completely abstract layer of operating system. So, here you can see that whatever layers are there in white, the topmost and the bottommost, which is the user and the hardware, all other layers which are in blue and gray can be summed up inside the operating system. So, the point which I am trying to make here is operating system is the entity which is going to sit between user and the hardware. It is going to provide the interfaces, it is going to provide the services, and it is going to provide many other required items, and it also manages those services. So, this is, we can say, it is a view of operating system services. So, till this point in this lecture, what we have covered is your we started from the kind of brief of time sharing operating system. Then we have covered many terminologies related to operating system and what kind of complications, what all services are required there, and then we have seen the various views of operating system, and we have basically we have just named them, and we have seen operating system services with the help of a diagram. But yes, detail of all these services is still left, which will be covering in which we will be covering in the next upcoming lectures. And here is a basically what I can say is the list of references which is being used for the preparation of this lecture. Hope you had a fruitful learning. Thank you for patient hearing.